Hi and Assalamualaikum. My name is Noor Binti Mohamad, and today I will explain about the experiment of control volume, which is impact of jet. Over the years, engineers have found ways to utilize the force that can be imparted by a jet of fluid on a surface diverting the flow. For example, the pattern wheel and also the impulse turbine that is still used in the first and sometimes the second stage of a steam turbine. Fluid jets are also used in industry for cutting metals and deburring. One way of producing the mechanical work from fluid under pressure is to use the pressure to accelerate the fluid to a high velocity in a jet. When directed onto the vanes of turbine wheel, the force of the jet rotates the turbines. The force generated is due to the momentum change or impulse that takes place as the jet strikes the vanes. Water turbines working on this impulse principle have been constructed with outputs of the order of 100,000 kW and with efficiencies greater than 90%.
The objective of this experiment is to determine the force produced by a water jet when it strikes a flat jet and hemispherical cup, and also to compare the result measured with a theoretical value calculated from the momentum flux in a jet. This is the setup of the apparatus. In this experiment, we will have impact of jet apparatus, hydraulic bench, and also stopwatch. So the picture here is the impact of jet apparatus, where we have weight pen, spring, nose screw, inlet pipe, level gauge, plate, nozzle, and also adjustable feet.
So this is the procedure of the experiment. Before the experiment is conducted, a quick inspection was carried out to ensure that the unit is in proper operating condition. So first, a hose connection is connected to the nearest power supply, and then the discharge pipe is opened. When assembling the reflector, the 3 screws on the cover are loosened and the cover is removed. And then plate deflector is fitted, the lock nut on rod is tightened, and the cover is screwed back. Number 4, the pointer is set to 0 using the adjusting screw. Number 5, the desired loading weight are then applied. Then the main cork is closed and the pump is switched on. Then carefully open until the pointer is on 0 again. Number 7, the mass flow rate is established by collection of water over the time interval. Further observation are then made at a number reducing flow rate. The best way to set the condition for reducing the flow rate is to place the jockey weight at exactly the desired position, and then to adjust the flow control valve to bring the lever to the balance position. The condition of the balance is thereby found without touching the lever, which is much easier than finding the point of the balance by sliding the jockey weight. And then the experiment is repeated twice, which is using the flat plate and also the hemispherical cup.
So this is the result of the experiment. The upper table is for the flat plate and the lower table is for hemispherical cup. So first, we look at the right calculation, which is the dimension of the apparatus. So we have diameter of the nozzle, and then cross-sectional area of nozzle, and then the height of vane above nozzle tip, and distance of the level L, as of jockey weight, and also the weight of jockey weight. When the jockey weight is moved a distance y from its 0 position, the force F on the vane, which is required to restore the balance, is given by F times the distance, which is 150, equals to weight times distance y. So we will get 0.03924 y Newton. And then the velocity note is equal to velocity u1 minus 2gs. The calculation on the right is the value from the table. So we will calculate the mass flow rate, the volumetric flow rate. Then we will calculate the velocity u1 of the jet as we leave the nozzle using the formula Q over A, and then the velocity at impact with u0 using the formula, and then the momentum flow in jet using the mass times the velocity u naught, and lastly the force on the vane F, which we use 0.03924 times with the distance y. Take note that the velocity of u naught, which the jet strikes the vane, is slightly less than u1 because of the deceleration due to the gravity. The force produced on each of the vane is proportional to the momentum flow in the jet as it strikes the vane. For the flat plate, the slope of the graph is 0.97 as compared with the ideal value of 1. The discrepancy is possibly due to the systematic error, such as error in taking the nozzle diameter. Further possibility lies in the behavior of the jet after striking the vane. It forms a radial sheet which impinges on the inner wall of the surrounding cylinder and then divides some of the water flowing down the cylinder wall, and the rest flowing upwards on the vane. For the hemispherical cup, the slope of the graph is 1.92. The maximum possible force is to be 2J, which occurs when the jet is deflected through 180 without energy loss. The ratio between the measured force and the theoretical maximum may be regarded as the efficiency of the weight of the vane, 0.96 in this case, and will always be less than 1 because losses will always happen in practice. Based on the result, the impact of the flat plate is half of the hemispherical cup. The hemispherical cup is more efficient for using in a turbine than the flat plate. But only one point to be considered is that the water to exit the cup is going to collide with the water entering the cup, which will reduce the force. For that reason, the cup is made in angles less than 180. There is slightly difference between theoretical value and actual value due to the experimental error. It is possibly due to the parallax error when taking the value, such as error in recording the water level that occurs because water valve was not completely closed, thus affect the time taken. In order to overcome the error we can ensure that the position of the observer's eyes is 90 degrees perpendicular to the reading. And then we have to ensure that the apparatus is functioning perfectly.